Hello guys, so welcome to our channel Rowan Basic. So in this video we will learn how to solve and define the concept of the inverse functions. Okay, so on our board we have here the inverse of a one-to-one functions. So our focus is all about one-to-one functions and how to solve its inverse. So before that, let us define the inverse of a one-to-one functions. So on the board, we have the definition. Let f be your function. Let f be a one-to-one function with domain A and range B. Then, the inverse of f denoted by f with your exponent -1, or we can read this as the inverse of f. Here, the inverse of f is denoted by this one. We have f with the exponent -1. So we will read it as the inverse of f. Again, the inverse of f. Not f raised to -1. Okay? So the inverse of f is a function with domain B and range A, defined by the inverse of f of y is equal to x. So I will explain it later. If and only if f of x, so we have f and only if f of x is equal to y for any y and b. So let's put it in here. Okay. Then we should remember that a function has an inverse if and only if it is a one-to-one function. So it means that when a function is not one-to-one, we cannot solve its inverse, or we can solve it, but we might get confused. Okay, so to explain its definition, let us go in here. We have here some illustration here. So a function with domain B and range A, and a one-to-one function with domain A and the range of B. So in here, we have your a function f and then its inverse. Okay? So example, the domain and the range of your f of x are in here. So the domain are 1, 2, and 3. And by the definition, the domain is denoted by A and the range is denoted by B. Okay? So the range A, example, we have values for your domain as 1, 2, and 3, and the values of your range B are 5, 6, and 7. Okay? So that is your f of x, or your function. Then, below the illustration of the domain and range of, the domain and range of your inverse. So that is how to illustrate. So the inverse of f of x, the domain are 5, 6, and 7. The range are 1, 2, and 3. Or you can say, based on this one, we have AB. On the inverse, we have BA. Or to make it simple, the domain and range of a function and its inverse are interchange. Okay, so simple as that. Or we can put it as just like this, your table of values. Okay, if you are comfortable with this, so x and y, or we can put f of x on your y. Okay, so the values of the range, example, we have 1, 2, and 3. The value of your domain are 1, 2, and 3. The value of your range are 5, 6, 7. So that is just an example. So this is the domain and range of your f of x, and this is the domain of the inverse of f of x. So they will interchange. It's as simple as that. So I just want to put in your mind that when we are solving a one-to-one function and its inverse, the domain of your f of x and the domain range of your inverse of f of x are interchange. Okay, so that is the concept, and we will use this concept in solving for the inverse. So let's go for the first example. Okay, so we have function f of x equals to 3x plus 1. So we will solve for the inverse of your f of x, denoted by the inverse of f of x. Okay? So we have some steps to follow in solving your inverse of a one-to-one function and how to solve it effectively. Okay, so our first step is change your f of x into y. Okay? So it means that f of x is equal to y, therefore y is equal to 3x plus 1. Okay, so easy. Then your next step is interchange x and y values. So we have y equals to 3x plus 1. So interchanging, we have x equal to 3y plus 1. So I'm sure that you get it. So y will become x and all the x will become y. So that is the second step. So the third step is, letter C, example, solve for y in terms of x. So we have to solve for y in terms of x. So if you can see your equation in here, we have x equal to 3y plus 1. So we have to solve for y in terms of x, or shall we say, copying your function, we have x equals to 3y plus 1. We're gonna put your equation in y form just like this one, or shall we say we will isolate your 3y on the other side. Then we have to subtract 1 here, because we were using a subtraction property of equality. So we have minus 1, so we have to minus 1 on the other side. Again, your equal symbol denotes balance. So minus 1, your positive 1 will be eliminated. So we have x minus 1 on the other side. The remaining term on the other side is 3y. Then you can divide both sides by 3 to eliminate 3 on your 3y. Okay, so dividing both sides by 3, the remaining on the other side is y. The other side will become x minus 1 over 3. Or, putting it, we have y is equal to x minus 1 over 3. So this answer will be accepted, but this is the most correct way of writing your inverse of the function. So you will ask me, this is the form of your inverse of f of x. So y is this one. Just copy your function. The inverse of f of x is equal to this one. Okay? So very easy. So that is your first example. If you can see and observe, we have 3x plus 1 or we have 3x plus 1. So the operation between 3 and x is multiplication. So we are talking about inverse. So the inverse of multiplication is division. So we have 3 times x. Now we have divided by 3. Then we have plus 1. So the inverse of plus 1 is minus 1. So if you have some knowledge on how to do the inverse of the one-to-one function, you can write it directly. But this is the basic and the fundamental step of solving the inverse of a one-to-one function. So let's go to the next example. Okay, for your next example, we have g of x equals to x cubed minus 2. So we will be solving for the inverse of g of x, denoted by this 1. Okay, so if it is f of x, so we have f inverse of x, but this time we have the g of x, so we have this notation g inverse of x. Okay, so I guess we were clear on that. So let us proceed. So step number 1, we have to change your g of x into y form. So we have g of x equal to y. Or you can interchange y is equal to g of x. It's up to you. Then, instead of g of x, we will write y equals to x cubed minus 2. Okay? Just to copy. Then our next step is to interchange the value or the domain and range. So y will become x and x will become y. So very easy. So we have y cubed. Then next step is to solve for your y. Or we have y cubed on the other side. And we have x plus 2 on the other side. Okay? Or you can write it as y cubed is equal to x plus 2. They are the same. So we have y on the other side, but it is not simplified yet. So we will have to solve y cubed is equal to x plus 2. Eliminate this cube or the exponent 3, we have to extract the root. So the inverse of cubing is cube root. So we have applied cube root on the other side, so we must apply cube root on the other side. So I will write it for you to see it thoroughly. So we have x plus 2, so cube root and cube root. Okay? So cube root will be eliminated. Therefore, the remaining is y equals to cube root of x plus 2. Okay? Or, this is in y form. If you have to put it on the inverse of g of x, you can say that the inverse of g of x is equal to the cube root of x plus 2. Very easy. Okay, so I guess we are clear on this example. Let us proceed to another example. Assuming you have h of x equals, let us put your example on another type of function. Okay, let's say we have your function h of x equals to 2x plus 1 over 3x minus 4. So you have a rational function, and we have to find the inverse of h of x. The inverse of h of x is denoted by this one. So let us solve it on a faster approach. So h of x will become y equals 2x plus 1 over 3x minus 4. Okay? Then, interchange. Your range will become your domain, so y will become x and all the x will become y. Okay? Just follow the steps. Then we have to cross multiply. We are just cross multiplying because the quantities are separated by your equal symbol, so we can cross multiply. So the denominator of x is 1, so we have to write it as x from here times the quantity, cross multiplying, we have 3y minus 4. So cross multiply. But the denominator of x is 1, so it is understood to just copy 2y plus 1. So we have just copied 2y plus 1 on the other side of your equation, because any number multiplied to 1 is equal to that number. So it is inconvenient to multiply it. So we will solve it the fastest as we can. Then we have to distribute by distributive property of multiplication. So x times 3y, we will get 3xy. Then 3 times negative 4, or x times negative 4 is negative 4x. Okay, so I guess we are clear on that. Then copy equals 2y plus 1. Okay? Then combine like terms. Put all the terms with y on the other side. Just like this. So we have 3xy minus y, minus 2y. Okay? Then we have plus 1 and 4x. Okay, so 2y is transferred on the other side, so we have negative 2y. Then minus 4x transferred on the other side, we have positive 4x. Copy plus 1, copy 3xy, so we have this one. Then continuing, we have, I will copy this one, or let's just continue in here. We have to get the common between 3xy minus 2y. So the common is y. The common is y. Then the common. After the common, what will be the remaining? So we have 3x minus 2. So if you have to check it, just multiply it using the distributive property of multiplication. So y times 3x is 3xy. Then y times negative 2 is negative 2y. Okay? Then copy 4x plus 1. Okay? Continuing, we have, I will copy in here so that you will not be confused. So we have y times the quantity of 3x minus 2 equals to 4x plus 1. That one. I will put the equal symbol in here. So we have to divide 3x minus 2 on both sides. So that the remaining will be y equals to 4x plus 1 over 3x minus 2. Okay? Or we can put it in this form. We have h inverse of x is equal to 4x plus 1. Just copying your answer in here. Okay? So that is how to solve for the inverse of a one-to-one function. So I will give you another example of a function, and let us solve and verify whether that given function has an inverse, or if that function do not have an inverse. Okay, let's try. Okay, on our example, this time we have t of x is equal to x squared plus 4x minus 2. So let us solve if the inverse of t of x exists or not. So we have the inverse of your t of x denoted by t inverse of x, or the inverse of t of x. So solving it the fastest way as we can. So p of x will be equal to y. So therefore y is equal to x squared plus 4x minus 2. Okay? The next step is to interchange your range and domain. So your y will become x and your x will become y. Okay, just copy the form. Then, isolating y on the other side of your equation. So we have y squared plus 4y. And this minus 2 will become x plus 2 on the other side using the addition property of equality. So minus 2 will be eliminated because we added 2, and of course if we added 2 on the other side, we will add 2 at the other side. Again, your equal symbol denotes balance. So we have this form. So after this form, to make it faster, we will have this procedure, completing the squares. So completing the square, we will be using b over 2 squared, or you can use b squared over 4. So identifying the numerical coefficients a, b, c of your trinomial. So the numerical coefficient a is 1, your b is equal to 4, and c is equal to x plus 2. But you can see the most important coefficient is the b. So we have to write it, x plus 2 equals y squared plus 4y. So we will be adding another quantity or term. Because we added a quantity, we will add a quantity. What did we add in here will be added in here. Okay? So b squared, b over 2 squared. So your b is equal to 4. So solving your b over 2 squared is, your b is 4, so we have 4 over 2 squared is equal to, square the numerator, we have 16, square the denominator, so we have 4. Then we have 16 divided by 4 is 4. Or by using your PEMDAS, we have to simplify first the quantity inside your parentheses. So 4 divided by 2 is 2, of course. Then square, we have 2 squared is equal to 4. So any procedure will do. So there are many ways to kill the cat. So we will add 4 in here. Because we added 4, we will add 4 on the other side, of course. Then the next procedure is factoring. So y times y is the factor of y squared. So what is the factor of 4? Of course, 2 times 2. So why did we use 2 and 2? Because the middle term is 4. So 2 plus 2 is 4. And because all the terms are positive, you will not to worry. Just use positive 2. Okay? Then copy x plus 2 plus 4 is equal to x plus 6. Okay? Then we have y plus 2 quantity squared. So why did we get on the form? So I will give you an example. Example, we have x squared. So x squared is equals to x times x. So the expanded form of x squared is x times x. Then we have example xy, quantity squared. So we have xy times xy. Example, we have x plus y, quantity squared. So we have x plus y times x plus y. Okay? What if we have x plus b quantity cube, or the cube of x plus b? So we have x plus b times x plus b times x plus b. So we are just adding the exponent of the terms using the law of exponent, which is the product rule. We will add the exponent of the quantity if the base are the same. Okay? So let's proceed, and that is why we have a quantity of y plus 2 times the quantity of y plus 2 is equal to quantity of y plus 2 squared. So that is the concept behind. Continuing, we have x plus 6. Okay? So I will write it in here. x plus 6 equals to y plus 2 quantity squared. Quantity squared. So how can we get over with the square? Of course, we have to do the square root. Because we did the square root on the other side, we will do the square root on the other side, of course. So the square root will be eliminated as well as the square. So we have y plus 2. Then we have the square root of x plus 6. Okay. Why did I write 2 in here but I did not write 2 in here? So, to be basic, I just write 2 for you to know. But if the index is not written, it is understood that the index is 2. We will read it as square root. So the smallest index of a root is 2. We don't have 1. Okay? So it is understood that the index is 2. So that is why square root in here and the root is extracted. Then we have y. Then we have x plus 6 square root minus 2. Or shall we write it in the form of y is equals to square root of x plus 6 minus 2. So in some books you can see that they put the quantity or the parentheses on the x plus 6 for us to identify that the square root is just on the quantity of x plus 6 and 2 is not part of the square root. Okay? When the square root is involved in a quantity, we have that plus minus. Okay? Plus minus. Or shall we say that the inverse of t of x is equals to plus minus the quantity of x plus 6 minus 2. So any of the two answers will be accepted. Okay? So I will focus in here. Or let's answer this question. If the inverse of this function exists. So based on plus and minus, this one, the inverse don't exist. Or we can say that this function is not one-to-one. Again, this function is not one-to-one. Or the inverse don't exist. Why? Example, we have square root of 4. Square root of 4 is equals to plus minus 2. Or we have two answers. We have negative 2 and positive 2. Because squaring this one is 4. Squaring 2 is 4. Okay, again, let's go back to the concept of a one-to-one function. Okay, so your domain 4, the square root of 4, or shall we say, the square root of 4 can be negative 2 or positive 2. So this is not a one-to-one function. This is one-to-many function. Okay? So I guess we are clear on this. And to give you another illustration and concept, why this function or the t of x don't have an inverse, if you can see the degree of your t of x, we have your quadratic degree. I am not sure about the graph of x squared plus 4x minus 2. But all function in a quadratic degree has a graph of a parabola. Either it opens upward or downward. So a parabola is a function. It can be this one. But this parabola is not a function because it will not pass your vertical line test. Because the vertical line test crosses or intersects at 2 points. So this parabola is not a function but a relation. So a parabola that is considered a function is these two functions. So you can check the exact function or graph of this function. But in a quadratic function, it can be a parabola that opens upward or downward. So going back to the other video and how to identify whether a graph is a one-to-one function or not, it will pass both horizontal and vertical line test. So vertical line test, it will pass because it intersects at only one point. But on a horizontal line test, it intersects at 2 points. So again, giving you the idea, all quadratic functions don't have an inverse. Example, this is the graph of your quadratic function. Its inverse will have the graph of this one, or it can be this one, because your domain and range are interchange. Or just look at 90 degrees. Okay? So that is how. Or that is why. So in summary, and to answer this question, the inverse don't exist. Okay, so I guess you have learned something from this video. Thank you so much and stay safe. So please subscribe.